In class today, we investigated what it means to be the solution to a linear system of equations. So I guess to know what that means, we first want to review what a linear system of equations is. A linear system of equations consists of two, or technically or more, but we'll leave it with two, consists of two linear equations. And linear equations being equations that have x and y. So a system of equations is nothing more than two linear equations. And the solution to that system of equations is going to be, at least if we stick to today's lesson, is going to be represented by the point at which the two lines that are graphed for those equations, where those lines intersect. We'll learn other methods as we continue further into the chapter, but for today, we're simply going to be sticking to graphing an equation for one line, graphing an equation for a second line, finding where those lines intersect, and representing that point of intersection as an ordered pair. And then what we can do is verify that ordered pair is the solution, because if we substitute the ordered pair in for x and for y, not just for one equation, but for both, we should get a true outcome, because that will prove that the point, the ordered pair, is on both lines. And conceptually, the only way you can have a point sitting on two lines at the same time is because those lines intersect, okay? So to go through that process, we're simply going to make sure that as we look at our linear equations, they are already in slope-intercept form. Now don't forget that's just simply y equals mx plus b. Once we get them in y equals mx plus b, after having gone through chapters 4 and 5, we should be very comfortable graphing each line, starting at our b value, and then using our slope to use our rise and run to count for other points. And then we should just simply identify the ordered pair and represent it, or identify the point of intersection and represent it as an ordered pair. So you can see in our first example that we'll be doing, both equations are already in y equals mx plus b. Y equals negative 1x plus 3. For the first equation, y equals 1x plus 1. When we get to the second example, you'll see we'll have a little bit of work to do, because this first equation is not in slope-intercept form. So we'll practice our skills for converting that equation so it looks like y equals mx plus b, so that we can move forward with graphing the line more easily. Okay, so the first thing we will do, and keep in mind, anytime we graph, we always want to have a ruler or some sort of straight edge. So to start with, we're going to graph this first equation at positive 3 on the y-axis. And then we're going to count our slope. We're going to count our slope by counting a rise of negative 1. Remember, this is like, so if we do rise over run, that's negative 1 over 1. So we're going down and to the right or up and to the left. That's for this slope right here, okay? So we can go down to the right, 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 and keep on going. Now as a reminder, as long as we have space to do this, we will continue that pattern of counting rise and run in both directions. So once I run out of space going down and to the right, I'll go up and to the left, up and to the left, up and to the left, accordingly. Okay, so that's the points, all the points for my first line. I'm now going to go back and repeat the process for my second line. So this is my starting point, is my b value. So I'm going to be at positive 1. And this time my slope is 1 over 1. So I'm going up and to the right, or I'm going down and to the left. Now what I'd like you to get in the habit of doing, so that you can clearly see your point of intersection. So here's our starting point, our b value of 1. When I go up 1 into the right 1, there is my point of intersection right there. I'm actually going to circle it so it really stands out for me, so that when I'm ready to identify that ordered pair, I don't have to be looking at it, because even with all these extra points here to keep a nice straight path with our ruler, there's still the risk of your line going a little bit off from its target. So if you see that one ordered pair that's circled, you know without a doubt, even if your line's a little inaccurate, that's where the lines are intended to intersect. But I really want you to make sure that you do that, just make a habit out of it. So we'll go up and to the right, up and to the right, up and to the right. We'll continue that as often as we can. And then we'll go in the other direction. Since we ran out of room going up one to the right one, we'll go down one to the left one, down one to the left one. Whoops, that's not the right spot. And I know with this sketch pad, some of my points disappear, but you're doing this on your paper, so your points are not going to disappear. Now, the only thing I haven't done yet is graph my lines. So again, I just want to make sure that I can clearly see that. So it looks like that ordered pair right there. I'm going to draw an arrow to it. That ordered pair right there. It looks like it's 1 for X and 2 for Y. So it's 1, 2. Whoops, 1, 2. Okay, so I'm going to do the best I can to freehand my line. And of course, you have a ruler to do this, so you're not going to have the same trouble that I am with the line being a little shaky. And this is what your graphed system of equations will look like. The blue line is the first of my equations, y equals negative 1x plus 3. The red line is the second of my two equations, y equals 1x plus 1. I've gone out of my way to circle that point of intersection once I hit it. And my ordered pair for that is 1, 2. So identify the point of intersection. That point of intersection is going to be 1, 2. So if we wanted to test that ordered pair is indeed the correct solution, we could substitute it back in to each equation and make sure it makes each equation true. So let's see, negative 1 times my x value of 1 is negative 1, plus 3 does give me my y coordinate in the ordered pair of 2. So it makes the first equation true. Let's see, now let's substitute into the second one. Negative 1, 1 times the 1 from my x coordinate is still 1, plus 1 equals 2, which is the y coordinate for my ordered pair. So it makes both equations true. So that is a great way of always verifying that your answer is correct, because all you have to do is spend the quick couple of seconds substituting in and checking that the ordered pair that you came up with makes both equations true. So don't overthink this. I'm going to have you do this next one on your own. You're simply going to take each equation and graph the lines for each and identify that ordered pair, and just make sure you state that ordered pair as your solution. So when you're done, you're going to state that ordered pair down here and then do a quick check. And by that, I really just mean a mental check, okay? Just do a quick mental check. Or if you need a calculator to assist you, then use it, okay? Because that's going to be a very quick investment of your time to verify you have the correct solution. So before I leave you to do that on your own, let's just see. Okay, so this one is already in slope-intercept form. There's my slope. There's my b value. However, over here in the other equation, I need to quickly convert this into y equals mx plus b. So the one step needed to do that is to add 2x on both sides. And my equation for my rewritten equation, slope-intercept form, is going to be y equals 2x minus 4. Y equals 2x minus 4. So there's my b value, and there's my m value. So again, make sure you go through the trouble of completing that first step that we had outlined up above, as you need to convert the equation into slope-intercept form first. So graph each line, identify the point of intersection, and list that ordered pair. And we'll do more practice in class tomorrow.